How are you, my friends? This video is presenting questions 15 to 28, Group B, from the 70 old exams review questions for the complete algebra course, lectures 1 to 39. Question number 15. If a polynomial of degree 4 with zeros 1 minus 1, 1 plus square root of 2, 1 minus square root of 2 is written in the form x squared ax plus b, x squared plus cx plus d. All these are integers. Find a plus b plus c plus d. So the idea here is to find the polynomial. So I can say the polynomial here is x minus c1, x minus c2, x minus c3, x minus c4. So I write all the zeros. You know, here I have to multiply. I expand here, x minus 1 minus square root of 2, x minus 1 plus square root of 2. Then I can use the difference between two squares. So this becomes x squared minus 1. Here it will be x minus 1 squared minus 2. Expand here. See, there's a 0, x squared. There is no x, so I put 0x minus 1. This one, x squared minus 2x minus plus 1 there, and minus 2 becomes minus 1. So here A is 0, B minus 1, C minus 2, and D minus 1. When you add, you get minus 4. Given a function f of x is equal x squared plus 4x plus 2 with domain minus 3 to 0. Then we need the minimum and the maximum value of f of x. So this is a multiple choice, A, B, C, D, E. So this is a parabola quadratic function. All right. So we can find h minus b over 2a, which is minus 2. And then find the k, which is also minus 2. So the vertex will be minus 2, minus 2. See, this is the vertex. Since we have a restricted domain, see the domain from, given there, from minus 3 to 0, from minus 3 to 0. That's the domain there. See, that's a restricted domain. So the minimum here will be minus 2 on the y value, and the maximum will be at 2. So the answer is E. Now, I modified this question. If I say the domain changed to 0 to 2, same function, same parabola, the domain from 0 to 2. See, here you can say f of 0 is 2 and f of 2 is 14. Because see, the vertex is not included in this domain here. See, from 0 to 2, this part of the domain. So the minimum here is 2 and the maximum is 14. But the other question, we have the minimum at the vertex. We have the graph here given. Find the equation of this function, the domain and range. This is a rational function. See, there's a vertical asymptote at 3, there's a horizontal at 4, and this is the graph. So how do we start? From the graph here, we look at the vertical asymptotes here, x equal 3. So in the denominator, we have x minus 3 there. Then we can write the equation ax plus b over x minus 3. Now the horizontal here, 4. See the horizontal, the leading coefficient in the numerator over the leading coefficient in the denominator. So a over 1 is equal to 4. So a will be 4. Now for the x-intercept, see, I can see here the x-intercept is 5. See, x-intercept y is 0, so I put 0 here, and x is 5. So cross multiply, you get 4 times 5 plus b is equal to 0, so b is minus 20. So now the function here, 4x minus 20 over x minus 3. Domain all real numbers except the vertical, and the range all real numbers except the horizontal asymptote. It's written there. F is a function such that f of 3 is minus 2. Find the coordinates of the point on the graph of function g. 5 minus 3, f of minus x plus 2. So this is a shifting, reflection, stretching question. So I put here two methods. F of 3 is minus 2. See, there's a point here, 3 minus 2 on the function, 3 minus 2. So I can, this is a quick method. xy is the given here, 3 minus 2. So what do I need to do? I have to change it to minus x plus 2. See, this is on the x. And then 5 minus 3y. So I can just replace x there and replace y there. See, the point will be minus 1 to 11. Another detailed method will be vertical stretching 3. See, multiply 3 times the y. Then minus y in the reflection in the x-axis. See, 3 minus 2 is the point here given, see? Multiply 3 by the y, vertical stretching, so minus 2 times the 3, minus 6. Then the reflection in the x-axis, minus y, so it will be 3, 6. Then minus x, reflection in the y-axis. So becomes 3, 6 here becomes minus 3, 6. Then 2 units to the right becomes minus 1, 6, and 5 units up becomes minus 1, 11. Same answer. Find the intervals where the graph of this function here, absolute value of all this, is increasing. We know that the inside function is a parabola, so we have to draw it. Then when we put absolute value in the function, we take all, see, this is the graph of the parabola. Let's find h here. H is minus b over 2a, 3k will be, f of 3 is 8. See, this one without absolute value. So the vertex 3, 8. And see, we have a minus 2 in the a, so it's opening down. See, this is the parabola now, without absolute value. Now, in the absolute value, we have to take all the negative part, you see, below the x. It will be above the x like this. See, this negative y becomes positive y. Now, we have to know these numbers, the x-intercept. Find x-intercept will be 1 and 5. So where the question, where the graph is increasing, this one here, increasing from 1 to 3, it's increasing like this, also increasing from 5 to infinity. Now we have a graph here of the function f. We need the domain and range of the function g minus half f of x over 2. Also, this is a reflection, stretching, and shrinking. See, the minus here will make a reflection. See, this is the graph here below the x. You see this one? This is the graph below the x. See, we have a minus. It will be reflected. And we have half multiplied by the y. See the half here, vertical shrinking. And then half of the x horizontal stretching. So the new domain will be minus 4 to 4, and the range will be closed 0 to 1. This is a rational function. The graph of this, x squared plus 3x minus 2 over 2x squared plus x plus 10 intersects horizontal asymptote. When x is equal to, multiple choice here, 14 over 5 minus half, 11 over 5 minus 2 over 5, 19 over 5. What do we do here? We find the horizontal asymptote, which is half here, because the leading coefficient over the leading coefficient. And then we make the horizontal asymptote equals the function itself. So we take this function equals the horizontal. And then we try to look for x. Cross multiply here. And then when you cancel 2x squared, you get x 14 over 5. Yes, so the answer is A. So this graph intersects the horizontal at x equals 14 over 5. Now find the number of points where the graph of this polynomial crosses the x. Crossing the x, we have to factor here more to make sure where are the numbers that have multiplicity odd. So the graph will cross the x. So this is x cubed already there. X squared minus 7, we can factor this. This is already power here odd. X squared minus 6x plus 9, we have to factor it. So this one here becomes x minus 3 squared. With the squared, it's power 4. See, this one, x squared minus 7, will be x plus square root of 7, x minus square root of 7. So we have at 0, it will cross. At square root of 7 or minus square root of 7, there are two numbers there. 5 over 2, because this is also odd. This will be tangent. So the number of points will be 4. So the function here f, see the function f will cross the x-axis at 4 values. Let's simplify this expression. 4th root of this, cube plus cube root of this. So this is index even, this is index odd. We have seen before, in the even index, you put absolute value because we have to make sure this is positive. In the index odd, no need for absolute value. Now, absolute value here, 2 minus square root of 5, that's a negative number. So we put the minus outside to make it positive. And this one, it will be minus 2 minus square root of 5. When you simplify this, the answer will be minus 4. Now, solve the equation. This is just a rational equation. To solve it, you can find the LCD and then multiply both sides. Remember, in the equation, you can multiply both sides by the LCD. So we factor x minus 8x plus 8, multiply both sides by the LCD, and then you get x, so easy, x equals 11. You have to check, remember, you have to check because sometimes we have 0 in the denominator here. If you put 11 here, 11 minus 8, 11 plus 8, no 0 in the denominator, so x will be 11. Where the graph is increasing, f of x is equal x times absolute value of x. You can take some points here to graph it. See, the black here is the f. And I put here extra, the blue is x cubed. Similar, but not the same graph. See, my method here is what? If I have absolute value on the x, so I take two cases. If x is positive, absolute value is equal to x. If x is negative, the absolute value of x will be minus x. So I take two pieces here, then I join them. So if x is positive, the absolute value will be x. So the function will be squared. See the square here, which is a parabola. So I take the positive. You see this black here from the red. The red is squared. The yellow is minus x squared. But I need the black. Now the second one I have minus x squared, which is the yellow. But I take the negative, so this is the negative part. So I join these two, it will be the black here. That's our graph. The cube I put only to compare. So where the graph of function f increases on minus infinity to plus infinity. If we have this function 11x power 5 minus x cubed plus 7x minus 5, using Descartes' rule of signs, P is the minimum possible number of positive, capital N is the maximum possible number of negative real zeros. Find P plus N. So you have to check here the variations. See the variations here, we have positive, negative, negative, positive, positive, negative. There are 3 or 1 positive real zeros. So P, remember P here is the minimum. So P is 1. If you put minus x in the function, see minus x, you simplify it, it has two variations. This is 1 and this is 2. So 2 or 0 negative zeros, 2 or 0. So n will be 2. So p plus n, 1 plus 2 is 3. Given the polynomial function here, you have to factor more. Let's complete the table below. Find the degree, list all distinct zeros. Distinct zeros means the different zeros. Describe the end behavior, where f is tangent, where f is crossing the x-axis. So you have to factor more, and then you answer the question. See, this one already factored, x squared minus 4, we can say x minus 2, x plus 2, and this one is complex, you know. See the complex, we don't take it in the real numbers, but we can write it there, or you can leave it x squared plus 4 all squared. So what is the degree? 9. See, there is 1 here, and there is 2, 3, 4, 5, 6, 7, 8, 9. So the degree is 9. List all distinct zeros, all the zeros. So the zeros are 0, minus 4, 2, minus 2, 2i, minus 2i. All the zeros there. Describe the end behavior. Up to the left. Why it's up to the left here? Because this is the leading coefficient is minus. See, up to the left, down to the right. So this is similar to minus x cubed. Where f is tangent to the x-axis, at -4 only. See, this is a real number, even here. Where f is crossing at 2, -2, and 0. So 3 values where the function is crossing the x. Given the rational function here, let's complete the table below. Missing points. Let's find the vertical asymptotes. Let's find the horizontal asymptotes, the oblique asymptotes, and the domain of the f. For sure, this function you have to try factoring up and down, and you simplify it first. If you factor this one, you get x common factor. So there's x squared minus 2x minus 3. And this is take a common factor, x squared minus 1. Factor again, this one, x minus 3, x plus 1, x minus 1, x plus 1. So we can cancel the x, but you have to put the condition, x cannot be 0. Cancel x plus 1, put the condition, x cannot be minus 1. So this is what's left over. So now what are the missing points? See, the missing points are the one that we cancel, -1 and 0. Then I replace -1 and 0 in this function to know the y value. So -1 will give me 2. 0 will give me 3. So these are the missing points on the graph. So when you graph it, there are holes here. Missing points means holes. Vertical asymptotes after we simplify it, not before, after. So x equals 1. Horizontal, after we simplify it, y equals 1. No oblique. In the same degree up and down. What is the domain? All real numbers except the cancellation and the denominator. So the domain will be all real numbers except 1, -1, or 0. Thank you for watching part B. If you like the video, you can subscribe and share it with your friends. And I hope I can see you in the C part of this, all the exams review questions. Thank you very much for listening. Bye.